Alright, I believe I'm live, and today we will be reviewing Reading How to Solve It by George Polya. Okay, so it's a very comprehensive and interesting book, like how we can solve any problem, any mathematical problem, or algo any algo problem. I believe George Polya do have the book name How to Solve It by Computers. So that is basically the CS version of this book. But yeah, widely it's say math is being derived into algo to solve CS problems. So this is the core thing that we have to understand. All right. So yeah, probably I am live at both of the places, Twitter and X, I mean, and at YouTube. All right then, we'll just start learning about these things. Okay, first let's have a basic review, or I can say a basic crisp version of this. So we have what it was Google Notebook, right? Notebook LM. We can hover over to it, and okay, I was just reading these things. We will make another notebook, and I will paste this link. Just write how to solve it by George Polya. Am I done? Okay, I can paste links here. Okay, let's see how it works, how these things works. Yeah, so it's basically art of solving anything. So yeah, it really explores George Polya 1945 book. Its application to modern fields like data visualization design. Okay, so he have four-step problem-solving framework, which involves understanding the goal, creating a plan, executing that plan, reviewing the results by comparing these mathematical heuristics to contemporary design thinking. Uh, so this article suggests that the structured logic inquiry can enhance creativity and technical work. That problem solving is a universal skill. Yeah, by internal questioning and use of analogy, ultimately it presents Polya's method as timeless rubric, a rubric for anyone looking to navigate complex information or improve their mental rigor. So let's first see what are the four step framework that Polya uh, described, or yeah, it makes sense. Let's see. So first, understand the problem. Yeah, the initial discovery phase, but how we can understand the problem? What do you know? What don't you know? Can you draw a diagram of the problem and notate its various part? Okay, so we can visualize the problem in a sense. Okay, I can understand that. Polya's noted that incomplete understanding due to lack of concentration is the most common deficiencies in problem solving. Okay, so just devise a plan. This steps involves finding a way to bridge the gap between data and unknown. Um, okay, strategies include thinking of similar or related problems you have solved before. Yeah, so we can get an idea that if we sense a similar problem, then we can solve it quickly. Yeah, it's the basic thing that we were doing from very start, but uh, understanding it at a very deep base level really helps a lot. All right, let's move ahead. So, thinking of similar related problems, decomposing the problem into smaller parts, or thinking about it differently. So, this is fine. We can decompose the problem into simpler parts, but how we can think about it differently? Like, what is different? I couldn't understand that. Okay, okay, I need to uh, see it from a different approach. Okay, so maybe this is the thing. We have to see the problem from a very different approach, maybe. So that's how we can move ahead with the problem and get a better grasp uh, of the problem. So this I really feel that we have to take a look into it. Okay, so adding auxiliary information or elements to help make sense of the problem. Okay, so what it is actually telling us. So we can add small information to the problem, and we can uh, small additional information. Yeah, and we can then make sense of the problem. Okay, if you can solve the problem, can you solve related problems? Okay, if I can solve the problem, can you solve related problem? So what this means, if the original were too difficult, try solving a related easier problem first. Okay, so let's say we have a question, uh, a combinatorics probability applied question, let's say. And if we can solve the whole problem, can we solve one part of the combinatorics? Yeah, Alright, and then let's see how we can carry out the plan. Yeah, literally do the math. Look back, can you check the result? Does your answer make sense? Can you use a solution for something else? After this, Polya spent rest of the book walking through 67 heuristics. Okay, but there are many wonderful concepts nested between the math solving approaches. In addition, Polya also explains the nature of heuristics. The aim of heuristics is to study the methods and the rules of discovery and invention, as well as heuristics reasoning. Okay, not regarded as final and strict, but as provisional, whose purpose is to discover the solution of present problem. Okay, throughout the book, the Polyas method is used over and over again as question and answer format to reveal the structure nature of the process. While this may feel obvious for some, the rigor of the approach is refreshing as it gives voice to natural processes many of us learn on help with untangle the messy world around us. Okay, so what I believe, if uh, in the book, in the original book, the Polyus method is used over and over again with different situations, different angles, so that we can just see our top view that if we have to reach the same solution but with a different situation, how we can reach it. So this might be the thought process. Okay, let's move ahead. So basically, first understand the problem. We need a plan, and we carry out the plan. We look back. I think these two are really important terms. First and second. Can I draw a diagram if I just follow this and make note of this? Wait. So first, we have to understand the problem. So understanding the problem means, okay, I will just uh, what do I know? What I don't know? Can I draw the diagram of the problem and notate parts? Okay, so basically, uh, I was just writing these thing in my note. Yeah, can I decompose the problem? So I can just copy paste it, but I want to write it in my own words. So, so it would be easy for me to just go through it and revise whenever I do want to. Okay. Okay, so can I think differently? Can I take a different approach? So this is the thing that I that is something wild, like not wild, but we have to think it very deeply. So it's not easy. Okay, 3 is execute the plan, nothing else. This is very important. Nothing else. No brainer. So fourth is we what we can take by seeing the result. Say reflecting back. So what does it mean? Um, does the answer make sense? Can I use this solution for something else? Okay, so I don't know what's correct spelling of George Polya. George. Okay, never mind. Okay, this is Georg. George. Okay, that's correct. Okay, so we have to figure out what are these two, what are these heuristics. So around like 1.5 years back, I was just reading some design heuristics uh, book. So I came across how I can think of, like, for system design, how we can think from our first principles and develop our own heuristics. Okay, so the legacy of how to solve it, teaching as a way of living. In late 1960s, Polya was speaking on his process of a class of elementary school math teachers. His comments were delivered with same precise and clever voice found in book. He speaks a lot about how kids can be mentally engaged with math through practice, and then passes along a list of ideas for teachers to do the same. Diagrams from how to solve it. Okay, so it basically describing that, like, we know teaching is not a science, so it have a lot of room to experiment and input our personal beliefs, personal attributes to it, and make it different. Yeah, whatever the subject, what the teacher really teaches is himself. This really resonates with me, so I have adjusted it, substituting the word teaching for database. Database is not science, it is an art. If were a science, there would be best way of teaching, and everyone would have to practice like that. Since database is not a science, There is a great latitude and much possibility for personal differences. An old British manual there was following sentence: whatever the subject, uh, what the practitioner really design is themselves. Okay, also listed some gentle advice and yeah. So as a teacher, what you should, what qualities you should develop, it's important, and these are some qualities that people should develop as a database as a teacher. Can I close this studio? Yeah. So yeah, this is the core thing. Be interested in your subject, know your subject, know about ways of learning. The best way to learn anything is to discover it by yourself. Yeah, it's really true. Try to read the faces of your students, try to see the expectations, difficulties, and put yourself in their place. Give them not only information but know how, attitudes of mind, the habit of methodology work. Yeah, it makes sense. So yeah, let's move ahead. Give them not only information but no, yeah, we read that. Like how we can, not only facts are good, but we need to figure out um how and why we are doing the things, how we can approach it. So what is this thing? Okay, heuristics or heuristic techniques is any approach to problem solving that employs pragmatic method. What is pragmatic? Okay, so it views uh, languages and thought as tools um, for prediction, problem solving. Yeah, got it. Uh, that is not necessarily optimized, perfected, or rationalized, but nevertheless good enough as an approximation or attribute substitution. Whether where finding an optimal solution impossible impractical, heuristic methods can be used to speed up the process of finding a satisfactory solution. Heuristics can be mental shortcuts that ease the cognitive load of making a decision. Um, okay, makes sense. So, heuristic techniques aren't optimized, they aren't perfected, they are just good enough to just move ahead. We can solve the problem and move to another thing that we are doing. These are basically the mental shortcuts so that our cognitive load uh, would be slightly less and we can make a decision quickly. Uh, okay, I don't know how to pronounce this. Let me just try. Jibignui Michael Weiss. Okay, I don't know how to pronounce that, but okay, it's fine. We will let's say I will just say it uh, Zedem. Zedem and David uh, Fossil, a well-known book on modern heuristics for algorithm design. Okay, this is just basic. In case you want to learn more, I will include selected quotes from Polya's across his 67 definitions of heuristics here. Okay, I will just read 67 definitions too. Um, Let me copy this. Certainly, I don't expect anyone to read this Cliff Notes version as the standard for original, but it's probably much easier to scan through them to become acquainted with concept. Who knows? It might help you in your creative process or inspire your process. Okay, so similar objects agree with each other in some respect. Analogous object agree in certain relation of their respective parts. Okay, so yeah, we can. Uh, Firstly, I do want to view the 67 uh, heuristics first. Later on, we can just jump to another thing. Let's just read 67 heuristics. Okay, so we are deriving it from this this thing. So it might not be showing the whole 67 concepts, but yeah, it's fine. It makes sense. Okay, so I'm back again. uh, I'll be constant now. So so below are the heuristic definitions and concept detailed in the sources. So what are the problem components here? Condition: a requirement that must be met. It is called redundant if it contains superfluous part, and contradictory if its parts are inconsistent. So what is contradictory here? A state where conditions are mutually opposed, resulting in no possible solution satisfying them. Okay, I think I read the same thing in the proof section of mathematics. So corollary: a theorem discovered early easily by examining another recently a found theorem. So it is literally a gratuity or trip. Okay, so this is just the basic thing, like what we have understand in the proofs, the the skeleton of the logic. This is same as that. Induction and mathematical induction. Induction is discovering general laws via observation of particular instances, while mathematical induction is a specific proof technique used in mathematics. Yeah, a lemma, an auxiliary theorem, or it is an assumption used to reach a larger goal. So problems to find versus problems to prove. Um, so a problem to find seeks unknown, whereas a problem to prove aims to show an assertion is conclusively true or false. Yeah, makes sense. Rather than it is just unnecessary parts. So reduction and reduction or reductio. Okay, so this might be a term. Yeah, shows an assumption is false by deriving an absurdly from it. So this is indirect proof established truth by showing the opposite assumption is false. Okay, so strategies for planning and transformation. So analogy: finding similarities in relation between parts of different objects to reach conclusions or conjectures. Yeah, so it's basically very basic things. So search and recognition strategies to reuse all the data. Yeah, execution and verification. Okay, mental attitudes and heuristic reasoning. Mm, yeah, it is really important. I think these two things are really important in anything whatever you do. These are important. What is this? Pedantry is rigid, unquestioning application of rules. Mastery is applying rules with natural ease and judgment. Progress and achievement, evaluating. So it is, yeah, we can just evaluate the things from this. Okay, so what are the new things? So what we can apply, what are the things that we apply? Okay, let's see this. This might be important. So yeah, this book describes four-step process that we saw: that we noted down too. And then creative thinking heuristics, the inventor's paradox. Ironically, a more ambitious, comprehensive plan can sometimes be easier to uh, succeed with than a restricted, narrow one. Uh, okay, this is kind of contradicting, but yeah, looks good. Decomposing and recombining. Break a problem into parts. Focus on one detail at a time, and then recombine them in a new original manner to find hidden solutions. Okay, so analogy. This is possibly the most essential kind of reasoning used to find parallels between different fields, like chemists using animal trials. Yeah, okay, makes sense. Auxiliary problems. If you hit a wall, create a secondary problem, then act as the stepping stone towards the ultimate. Okay, it seems really good. I can just apply it. So, so most of the time people do hit walls. So if you ever hit a wall, you can just apply it. So this is one thing. Things that can apply. Okay, this is actually a good way to break down the things. So mental attitudes for success. Look at the unknown. Keep your goal constantly in the mind. Yeah, mastery over pedantry. Apply rules with natural ease and judgment rather than rigid habit. Or pendant apply rules indiscriminately while a master notices specific nuances of the situation. Examine your guess, never disregard a vivid guesses, instead treat it as fragment of truth that can lead to a better idea. Determination and hope. Solving serious problem is not purely intellectual, it requires willpower that can survive years of toil and bitter disappointments. Okay, there are few more things that I want to note down. This thing, like keep your end goal always constantly in your mind, because okay, I have learned from Luffy too. He always says that he wants to be king of the pirate, and eventually one day he will. So it's really good. We can just derive that concept from One Piece too. So makes sense. Okay, examine your guess, never discard. Okay, we read that, and yeah, this also makes a good sense. While a master notices specific nuances of situation. Um, yeah. So basically, uh, let's say we have some set of rules, like one like people, let's consider two peoples. A, let's say people A, so he just applies the rules everywhere and anywhere, but B thinks about the situation and apply the rules accordingly. So here B is kind of doing mastery in it, whereas A is just a pendant. So self discovery, best way to learn anything is discover it yourself. In creative work or teaching, suggest it. Do not force it down their throats. Yeah, reflecting yourself. What we design or share with other is rarely just about the subject. It is reflection of who we are as people. What we design or share with others is really about the subject matter. Yeah, it makes sense. Iterative refinement. Even after finding a solution, seek a clearer or less roundabout way to derive it. So even after finding a solution, okay, it makes a really good sense. We can use it anywhere, especially in maths or in real life. So let's say we find solution from standard methods, but we can use different methods or something different. So we can come up with different methods so that we can just use it uh, as shortcut or just brainstorm over it. Okay, let's see how we can use this thing, inventor's paradox, in practice. The inventor's paradox is the idea of more ambitious, comprehensive plan. Yeah. So simplifying through generalization, in many cases, a specific restricted problem is difficult because its unique constraints are confusing and distracting. So yeah, I just went through this page, and so we can so basically, um, what is this inventor paradox in in crux is, so what we can do here is, don't just think of a narrow problem, think of the bigger picture, a more ambitious problem that you can solve in this path only. Yeah, so probably this is it. So in practice, these examples succeed because focusing too narrowly on a specific problem can cause solver not see forest for the trees. Okay, too many minute details can become a burden on mind. By shifting a more ambitious gender standpoint, that solver can discard unnecessary details and focus on essential points uh, that lead to breakthrough. Okay, so what we have to do is discard the unnecessary details and focus on the important points. Just no color. Okay. Okay, let's just read more about this. So let's see how we can decompose and recombine the things to find the solutions. Yeah, in case of decomposing, we can just uh, break the problem into parts. Initially, you may have a vague impression of the problem as a whole. To gain clarity, you must focus on the attention of specific details one by one. Identify the parts. Yeah, separating condition. A key step in decomposing is separating a various part of condition to consider each one by itself. Okay, so